All right, solving trig equations, everybody's favorite. Much like I did in class, I'm going to go through a couple of examples, give you guys a couple of strategies, and then, or actually 5 strategies, and then do one of the harder examples. One of the basic ones are going to be if you have just one trig function in your equation, like we do here. So I only have cosecant here. That's what you're going to go through and solve for. So I would start off here with 2 cosecant theta minus root 5 is equal to 0, and just you're going to treat cosecant theta just like a variable. So add square root of 5 to both sides, divide through by 2. So cosecant of theta is going to equal square root of 5 over 2. Now for the ones, before I forget, I'm going to pull up my calculator here. And what will end up happening here is that if you have one of the cousin functions, as I call them, cosecant, secant, cotangent, you're going to change it into one of the ones that you know. So like, for example, sine of theta is now going to equal 2 over root 5. And so if you rationalize that, sine of theta is going to equal 2 root 5 over 5. If the numbers that you get are ones that you normally see on your unit circle, 1/2 or 0, 1/2, square root of 2 over 2, square root of 3 over 2, or 1, or obviously the opposites of those. Or if you're dealing with tangents, you're going to have like square root of 3 over 3, square root of 3, 1, etc. Undefined, 0. You should just be able to pull your angle measurements or your radian measures off of that. Otherwise, what you're going to do is you're going to pull our information from the inverses. And let me get this here. And so then you're just going to go through and I'm going to move this over. My apologies. We're just going to go through and we're going to do inverse sine of 2 root 5. Now again, with these things, please make sure that you use the right set of parentheses. So that's 2 root 5 divided by 5. And we're going to come up with 63.43 degrees. So theta is 63.4 degrees. Now, remember, as we talked about with inverses, there are 2 places on the unit circle where sine is positive, 2 places where sine is negative, 2 places where cosine is positive and negative, 2 places where tangent is positive and negative. If we go back to your axes, okay, remember quadrant 1, both coordinates are positive. Quadrant 2, x is negative, y is positive. Quadrant 3, both are negative. Quadrant 4, x is positive, y is positive. Also remember that these go in order of cosine, comma, sine. So your x value is sine or cosine, y value is sine, and the tangent is sine over cosine. And so what ends up happening is that sine is going to be positive in these two. So like here, we've got this angle here. We're going to draw it out. Reference angle here is 63.4 degrees. That means that we have another angle with a reference angle of 63.4 degrees, and that's going to be the other in the other quadrant where sine is positive. So this is going to be 63.4 degrees here. Only problem is, of course, we don't measure angles from there. We measure angles from over here from the initial side. So we have to figure out what this angle is all the way over to here. And for that, that means, again, it's going to be 180 minus 63.4 degrees. So your other angle that you've got here is going to be 116.6 degrees. Okay, so that's going to be your 2 values for theta. Now, I know some of you would very much like to say, well, can you give us a set of, if it's sine, do this, if it's tangent, do that, if it's cosine, do this. And I could, but that'd just be more things that you'd have to memorize. I would really like you guys to be able to look at the axes and say, okay, sine is positive in quadrants 1 and 2. Angle here is 63 degrees, 63.4 degrees. That means that this angle over here would be, I guess the supplement to 63.4. I want this one right here. If you're talking about negative sine, okay, I'm in quadrants 3 and 4. Reference angle would be x here, solve it out. Oh, that's going to be 180 plus that reference angle, much like what we did back in March at the beginning of chapter 5. Okay. And in general, with the exceptions of the facts when sine or cosine is equal to 1 or -1, you're always going to get two answers out of this. You are not going to receive full credit on these problems if you only give me the one angle that your calculator gives you. So you need to be able to solve out the other one. Another example like this. Now here we're dealing with radians. Again, start off with the basic equation, 3 cosine x sine squared x is equal to cosine x. Now, one of the things you're going to have to ask yourself is, can I factor something out? So you're going to set everything equal to 0. So I'm going to move the 1 cosine x over. And do not try to combine these two terms. You can't do it. Don't even try. So I'm going to factor out the cosine x because it's the same thing that's in between the two of them. So I have 3 sine squared x minus 1. And then by, the good old a times b equals 0, zero factor theorem. So that means that either cosine of x is equal to 0 or 3 sine squared x minus 1 is equal to 0. This one right here, it happens two different places. Where is cosine of x equal to 0? Where is your x values on your unit circle equal to 0? Okay, the only two places where that can happen is going to be at 90 degrees and 270 degrees. Now, again, we're doing these in radians, and so because we're doing them in radians, we're going to convert this to pi over 2, and this is going to become 3 pi over 2. Now, oftentimes I'm going to do these things in degrees just because it's going to be easier to see initially, and then we'll convert them over later. Now, for this one over here, and other times they're just going to go through and they're going to ask you to kick them out. So when we solve this one, you're going to get to a point where you can say sine squared x is going to equal 1/3. Because again, I'm going to add the 1, divide by 3. How do I get sine by itself? You're going to square root it. Now again, remember you get plus and minus here. So sine of x is now equal to plus or minus the square root of 1/3, which again is going to give you plus and minus 1 over root 3 because the square root of 1 is 1, and then rationalize plus or minus square root of 3 over 3. Now if this was a tangent, that would be significant to be on your unit circle. When it's not a tangent, so you're going to have to go through and use your calculator, which again is fine. That means x is going to equal the inverse sine of square root of 3 over 3, and x is going to equal the inverse sine of a negative square root of 3 over 3. So, calculator out. Make sure you're in the right mode. We are now doing radians, so we need to go to radians. So inverse sine, clear this out so we don't get confused. Inverse sine of square root of 3. Close your parentheses, divided by 3. Enter. Okay. X here. Oops, sorry. 6 points. They usually have you go like 3 or 4 decimal places, so we'll do 3. 0.615. A couple of things to remember on a unit circle. This is pi. This is 2 pi, right? So this is at roughly 3.14. This is going to have a value of 6.28. So that means up here is going to be about 1.57. Okay, so this is in quadrant 1 because it's between 0 and 1.75. Now, where else is sine equal? Where else is sine positive? Okay, sine is positive in quadrant 1 and in quadrant 2. So that means that here, essentially, I've got this arc length that is this big here. That's 0.615. That means I also have this arc length over here that is 0.615. So to find the balance of this is going to be pi minus the 0.615. So we'll just go ahead and do pi, sorry. Pi minus 0.615. So the other angle is, or the other radian measurement is going to be 2.52. Oops. 7. We're going to do the same thing over on this side. Now, please remember, as I said in class, I'm not going to have you guys, everything we're going to do, your book does radians and, I'm sorry, let me start over. Your book does everything in terms of radians and degrees. For this very reason, since this gets a little bit involved in terms of are we doing things in terms of pi or not, etc., we're just going to work on doing everything in degrees. Okay, so this one is going to be x equals a negative 0.615. Now, two things here. Obviously, if we're going down this direction, that's not between, because all of these things are usually done for, actually I have it up here, for between 0 and 2 pi. So negative is not between 0 and 2 pi. So we're going to have to add on 2 pi to this. So your first one is going to be that plus 2 pi. Anyway, so as I was saying, on your reality check, you're going to do everything in degrees, so you don't have to worry about, messing with all of this. I'm sorry, my memory is failing a little. Okay. So that's one of them. Now this 0.615 is going to be over here on this side too. So like right through here. So again, you're going to go through a full pi plus that. So that'd be the other one. So you're going to do pi plus 0.615. And so then the other one is going to be 3.765. Okay, so those would be two of your answers, and this would be answer 3 and answer 4. You'd be doing these all in degrees. If you did these in degrees, what would end up happening is, let's say, for example, let's see, mode, change back to degrees. And let's go back, not that one, not that one, that one. Okay, so you would have negative 35 degrees. So you would add 360 on that to get it within the circle of 0 to 360. You would have a reference angle in quadrant 3 of 35 degrees. So you go 180 plus 35. So you get 215 degrees that way. Now, as I said, some strategies for you. First strategy is simply look at it. Is it linear form? Is it quadratic? Is it factorable? If it's a linear form, you just have to solve for just that trig function. If it's quadratic, you can factor it. Well, this was actually more like example 2. This was example 1. Quadratic, you can actually see stuff, and that's what we're going to do next. And I'm going to pause this for now. Number 2, you've got, is it just one function? Solve for that one. 3, if it's more than one function, try setting it all equal to 0 and then factor something out. That was like the second one we did. 4, use a quadratic formula if it doesn't factor. And last but not least, use some trig functions. I'm going to do a second part of this for a quadratic example. See you guys in a little bit. Check that out if you want to.